Good morning, everyone. Welcome to the lecture for week 6 of computer systems. So the first thing that I want to do is talk a little bit about the homework schedule again. The next thing that we have coming up is homework 5, where you're going to be implementing something called shell command tokens. And that actually ends up being the first component for challenge 1, where you'll be writing a Unix shell. The shell is the component of an operating system that accepts user input, allows you to launch programs and things. And a traditional Unix shell is a text-based thing. In fact, I have a Unix shell right over here. But we also could use the word to talk about sort of graphical shells, which every operating system has one nowadays, and that's whatever mechanism you're going to use to do input with a mouse and run programs by clicking on things or whatever that is. But when we talk about a shell in this class, mostly we're talking about a text-based shell, and specifically the program that is running in this window over here. This is a terminal window. The program that's running in the terminal window is a shell called bash, which is the sort of standard shell on Linux. So what we're doing is we're sort of building towards challenge 1, where you'll be able to write your own shell. And it turns out that it's a little bit more complicated than it looks like, but it also includes the complications that you'd expect, like being able to accept text input, and then respond to that. So the first demo that I want to do right now is I want to go ahead and start writing a program that will in fact accept text input. So let me head over to our Scratch directory. And then this is going to be video 6. And then we're going to start off with a program called cstandard.c. What we're going to do here is we're going to write a program that is going to do file I/O, because it turns out that I/O to files and I/O for like users typing things in and printing to the screen is the same mechanism on Unix or Linux systems. As we talked about previously when we were dealing with assembly, we talked about file descriptors, but that's also true as we're writing C code. So here's our test program. We're going to start by including standard I/O, because we're going to be using the C standard library to do file I/O. Now, I've typed this standard layout for a C program a lot of times, but I'm going to type it a lot more times. So what we're going to do is we're going to create a variable which is a file pointer. Now that all capitals file type is probably some sort of struct, but it's built as a sort of opaque type in the C standard library, and normally we don't worry too much about what it is, much less what's in the struct, assuming it is a struct. So to open a file, we use fopen. You can see the manual page for fopen says it's going to take 2 arguments. First, we have the name of the file it's going to open. And second, we're going to take something called a mode. Now, the mode, there are some options here. One of them is the mode, which is the string W, which means that we're going to open a file for writing, and we're going to truncate the file to 0 length if it already exists. So we want to create a new file that we're going to write to, and if something's already there, we blow it away. When we're done with a file, we've opened it, we got back a pointer. Now, if we call a function and get back a pointer, the first thing that we want to ask is, where did the memory for that pointer come from, and are we responsible for freeing it? And when we're dealing with something like a file, it turns out that we're not just worried about memory as a resource that we have to clean up. We're also worried about the file handle, which we know how that works. It's a file descriptor that goes in the file descriptor table. But that means that we have at least 2 things to clean up. We have to clean up the memory, and that file descriptor. So when we get a file pointer back from fopen, the thing that we do with it when we're done is we call fclose, and that cleans up the entire opaque object. Now, if we want to output to a file, we can use fprintf, which is just like printf, except we specify an additional argument at the beginning, which is the file that we want to print to. And then we can go ahead and give this a try. If we go ahead and let me write a quick makefile just for convenience. So our sources are going to be the thing that we get if we look at all of our C files. Our programs are going to be what we get if we well, let me call them binaries. Are going to be what we get if we take that sources list and we replace all the .c extensions with nothing. Now we're going to have an all rule in our makefile that's going to make all of the binaries. Now we have a rule that we can build a binary from a .c file. And all right, let me pause for a second. I'll be back.